Okay, so 2.7 is measures of spread. So we have our three measures of spread, which are going to be our range, our variance, and our standard deviation. Okay. The range is the absolute spread of the data. So that is just going to be your biggest number minus your smallest number, what values you're looking at. So the formula really isn't a formula. I'm just going to say biggest minus smallest. For the range. The variance is the average of the squared differences from the mean. It gives you kind of the absolute spread, like how it could be if I projected it to a population. You're going to be asked to calculate it. We're not going to use it in this class. So we're just calculating it, but we need the variance to get the standard deviation, which we are going to be using. So the standard deviation is the calculated value that measures how far, and that should say data, values are from their mean on average. Okay, so I like to say for standard deviation, it's like a give or take. So you might see something in, like, you pick up a newspaper article and it's like the average length of stay for COVID patients is 2.8 days in the hospital or something like that, right? Well, that's average, but you guys know that averages can be skewed by a lot of different things and not everybody's going to be the average. So then you have this standard deviation that comes in. So it's like, well, give or take a day. So it might be 2.8 days, but it might be like a day, and it might be like 3 or 4, so that's a give or take. And then the further out, with the standard deviation you get, then you can encompass the entire population. So that's kind of what the standard deviation is. And then the standard deviation is always going to be the square root of the variance. So we're just going to write here square root of variance. So you're going to actually do the variance calculation, and then you're going to take the square root of it to get your standard deviation. So I'm going to give you the formulas, and like I told you before, they are on the formula sheet. So you don't have to memorize them. They're a bit overwhelming when you first look at them. So don't be scared. There's 4 different formulas here for standard deviation because we have to sort data on whether it's going to be a sample or population and whether it's going to be grouped or ungrouped. So I'm just going to kind of separate this here. Yeah. That's going to be the best I can do for that. Okay. So we're going to start with a sample and a ungrouped sample. So remember, the standard deviation is the square root of the variance. So I'm going to give you the variance. So I'm just going to write VAR for variance. Okay, so it's going to be S. Okay, remember your sample calculations are English letters. So we say S squared equals, and then it's going to be the sum, so sigma x squared, so the sum of x squared, minus, and then we have parentheses, the sum of x, and then that squared over n, so our sample size, over n minus 1. And then the standard deviation, which I'm just going to say SD, is the square root of that. So we just say S equals the square root of S squared. Okay, now if we're looking at a population, the calculation is slightly different. So you have to look at whether you're doing a population or a sample. So this is going to be a population ungrouped. Now population uses Greek letters. So for our variance here, we're going to use sigma, which is a lowercase s. So it's like a circle or like an O, but with a line going to the right. So sigma squared equals, and it's basically the same except for the denominator. So you have sigma, or the sum of x squared, minus, then you have the sum of x in parentheses, squared, and then this is going to be over capital N for your population. And then the whole thing, instead of being over n minus 1, is just over n. And then the standard deviation is going to be, we say sigma. Let's see, there we go. Equals the square root of sigma squared. Okay, then group data, we introduce the midpoint. So if you come over to the right top, we'll do sample grouped. Or sorry, ungrouped. We'll start with ungrouped over here. No, grouped. Just kidding. Okay, so sample grouped data. We're going to start with the variance. So that'll be S squared equals, and then we'll have the sum of the midpoint squared times the frequency. So M squared F minus parentheses sum of M times F squared over N, and then that whole thing over N minus 1. And then the standard deviation is the square root of that. So square root of S squared. And then the last one is population group data. And then so we have the variance. We have sigma squared is going to equal the sum of M squared times F minus the sum of M times F squared, and then that over N, and then the whole thing over N. And standard deviation will be the square root. Okay, so again, those are all on the formula sheet. All right, we just have to know when to use, how to use, which we're going to do. Now, if you need a key for these, just like with the letters, those aren't, they're kind of, if you read up on the formula sheet, they're up a little bit, but you have, you know, S stands for standard deviation of a sample. We have the sigma is the standard deviation of a population. You had that uppercase sigma, remember that's sum. Okay, X are just your data values. Let's see, we have here N, that's your sample size, so how many? Then N, capital N, that's population size. M, midpoints. And then F is frequency. So I think I got all the letters there. All right, so I'll give you guys a minute to finish copying that down, and then we'll look at some of these examples, and we'll do them. Question?
Is it the whole fraction that's squared, or is it just the part?
Just the part in parentheses. Mm-hmm.
And those are the variables we do the whole course, right?
Yes.
Okay.
Yes. I can't seem to find my mouse. There it is. Okay, so this first example here, you have the data below give the salaries in thousands of dollars of all 6 employees at a small company. So first of all, we have to ask ourselves 2 questions. Is this a sample or a population? And is it grouped or ungrouped? So I heard population, right? This is a population. All 6 employees. And grouped or ungrouped? Ungrouped, good. Just single data values are ungrouped. If you look at 7.2, there we go. If you look at 7.2, that's grouped because you have these commute times that are ranges of values. These are just single values. So it's a population, it's ungrouped. We want to find the range, the variance, and the standard deviation. Range, smallest number, or biggest number minus the smallest. So range is going to be, what's the biggest number here?
108.
108.4. Smallest? 52.5. So let's go ahead and do that. $55.9. So the range of salaries spreads about $56,000 at this company. Okay, then we want to find the variance and the standard deviation. I did not give you guys enough room on this piece of paper. I'm sorry. Okay, I'm going to go over to another piece of paper. When you're doing these by hand, it's helpful to make like a table. So you might want to get a piece of paper for this. All right, so I'm going to write my values out, and you can put them in order if you want. You do not have to. But I'm going to put my X values, and I'm just going to list them out. So I've got 88.5, 108.4. Let me go over here. All right. Then I have 65.5, 52.5, 79.8, and 54.6. Okay, you guys can look above and see what calculation we need. I'm going to go ahead and write it off to the side just so we have it. So it is a population. So I'm going to be doing the sum of x squared minus sum of x squared over n, and then that whole thing over n. So I need a couple things. I need n, which is 6, so I got that. I need the sum of x squared, and I need the sum of x. Okay, so first thing we'll do is we'll find the sum of x, because that's easy. We just add this column here. Okay, so I'm going to go ahead and add that. So 88.5 plus 108.4 plus 65.5, 52.5, 79.8, 54.6. So 449.3 is my sum of x. Okay, now I need the sum of x squared. So to do that, I have to square each of these values. So I need another column here of my x squared values. So I'm going to go ahead and put those in. I'm going to do these on my calculator here. So 88.5 squared is 7832.25. 108.4 squared, 11,750.56. 65.5 squared, 4290.25. 52.5 squared, 2756.25, 79.8 squared, 6368.04. 54.6 squared, 2981.16. Okay, so let's get the sum of all of those. That'll give us our sum of x squared. So I'm going to put that up here. So we've got, let's see, 7832.25 plus 11750.56, 4290.25, 2756.25, 6368.04, 2981.16. All right, so there I get 35,978.51. All right, let's go ahead and put this into the formula. So that'll give me sigma squared equals the sum of x squared, which is here, so 35,978.51, minus the sum of x, so 449.3, squared over n, so over 6, and then all of that over 6. So once we get those values in, that's just algebra. So parentheses exponent. So I do 449.3 squared first. So 201,870.49. I can write that down. Just copying down the next step here. So next thing I would do would be to divide these by 6. So divided by 6. So 33,645.08 would be the next. So I'll go ahead and write that down. What was it? 33,645. So we'll subtract, and then we will divide by 6. So 35,978.51 minus, I'm just going to subtract this. So I'm just going to hit the second negative button where it says ANS because it just pulls the previous answer. So second answer. So 2333.428, then divide by 6. I get 388.90, and I think it's 3 decimals in your homework. So 388.905. So that's your variance, 388.905, which means then the standard deviation is the square root of that. Okay, so we'll go back to the calculator, and we'll go second square root, second negative, pull up that previous answer, 19.721. So variance, standard deviation. And then going back to that example, what does that mean? You would say, all right, this company has salaries. So the average salary, which we didn't find, but we can if we want. The average salary of company X is, you know, whatever that is, with a standard deviation of 19.721, which is $19,000. So it's got an average of I think I have it on here. Well, really, it's just the sum of x divided by 6. So 449.3 divided by 6. 74.88. So the average salary of company X is 74 grand, 75 grand, with a standard deviation, so give or take 19,000, which is a big range, but you only have 6 pieces of data, so that range is going to be a lot bigger. When you have more data, the standard deviation gets smaller.
Does that mean at least one salary falls within that range,
Mhm.
plus or minus?
There's actually going to be, so when we get to 2.8, there's like a certain percentage that'll fall within one standard deviation, then a certain percentage for 2, and then 3. Now, this is a pain in the butt to do by hand, and it's really easy to make a mistake, right? You can do this in your calculator. Okay, so let me show you how to do that. So first thing you want to do is you want to put this in a list. So you guys remember how to do the list, right? So put data in L1. That's going to be step 1. Okay, then once it's in L1, we're going to go to stat and then calc. And we're going to calculate our one variable statistics. You're going to L1 in your X list. Oh, I'll show you. And calculate.
Are we able to use a calculator for the test?
Mm-hmm. Yeah. All right, there you go. I'll show you. Write that down and then I'll show it to you. Okay, so if I put this in a list, so I'm going to go to stat, edit for my list, and then I'm going to go up to L1 and clear it because I got stuff in there. Enter. Okay, I'm going to put this in. So I had 88.5, 108.4, 65.5, 52.5, 79.8, and then 54.6. All right, so I go back to my home screen. So second, quit, and then stat, over to the right, calc, one variable stats. My list is L1, frequency list I'm going to leave blank, and then hit calculate. There's my mean, 74.883, my sum of x squared. Then I have these two values. So we had this 19.721. What's this one here, this SX? If it were a sample, 20.602, because the calculator doesn't know if it's population or sample, so it gives you both. So on a multiple choice test, both of those are going to be on there. You're going to have to tell me which one it is. Okay? And then remember, scrolling down, that gives you 5-number summary. All right. Let's go back to, okay, so go back to the notes. 7.2. I would like to, if we have time to do more examples at the end, we will. But I want to get through these. All right, so this says the following data give the average commute time in minutes for 25 employees at a large company. So, let me get a different color here. All right, first of all, is this a population or sample? This is a sample, 25 employees. Is it grouped or ungrouped? This is grouped. Okay, I think we should have enough room on this one. We'll do it by hand, and then I'll show you guys how to do this one in your calculator. So you have your commute times. Those are grouped into times of 10 minutes, which is nice. Those are easy to find the midpoints. Then you have your frequencies. So you have the columns here. On your test, I think I give you blank tables like that. I know I have in the past, so that you can fill it out if you need to, okay? But usually they're just going to give you, like on the homework, just these two. And then you would make your own columns. But you need the midpoint. You need the midpoint times the frequency. And you need the midpoint squared times the frequency for the formula. Okay, so if you look above, you have that formula for sample grouped. So we can write that over here if we need to. So S squared. So sum of midpoint squared times the frequency. So we're going to need that. We need the sum of midpoint times frequency squared. We need n, which is 25. And then n minus 1. Okay, so let's get the midpoints. The midpoints, if you guys don't remember how to find them, you're just going to add these together and divide by 2. So this one would be 5, 15, 25, 35, and 45. Then you have MF, which is midpoint times frequency. So 5 times 4 is 20. 15 times 9, 135. 25 times 6, 150. 35 times 4, 140. And then 45 times 2 is 90. And then we'll add that column together to get the sum of our midpoint times our frequency. So 20 plus 135 plus 150 plus 140 plus 90. So 535. Okay, for our midpoint times frequency. And then we want midpoint squared times frequency. So we need to square. You can make another column for squared if you want. You don't have to. And then multiply. So usually for here, I would just go 5 squared times 4. So 100. And then 15 squared times 9. 2025. Then 25 squared times 6, 3750. Then 35 squared times 4, 4900. And then 45 squared times 2. 4050. And then we'll go ahead and add all of those together. So 100 plus 2025 plus 3750 plus 4900, 4050. That's it. So 14,825. It's going to be that sum here. Okay, so if we put that into the formula, then here for our standard deviation, we'll do the mean in a second. So our variance, so the sum of m squared f, that's this 14,825, minus the sum of mf, which is 535, squared over n, which was 25, divided by 25 minus 1. And then we will make sure we do order of operations. So we'll do 535 squared first. I'm not going to write out each step on this one. So I square first, then I divide by 25. So I get 11,449 right there. So then I have 14,825 minus 11,449. And then I'm going to divide that by 25 minus 1, which is 24. So that gives me 140.667 for my variance. Then for the standard deviation, I'm going to take the square root of that. So the standard deviation is the square root. So I'm just going to go second square root, second answer, 11.860. So there's my standard deviation. And then I think I also wanted the mean. So remember the mean, that's x bar. That's the sum of the midpoint times frequency over the sample size. So we had already found that as 535. So it's 535 divided by 25. So 21.4. So if we wanted to say something about this one, this is, okay, at a large company, the average commute time is 21.4 minutes with a standard deviation of 11.860 minutes. Still, that's pretty big. Standard deviation, again, 25 may seem like a lot when you're doing the calculations, but it's not. In your calculator, you need to put these in lists. In L1, you're going to put your midpoints. So you still have to find your midpoints. And then in L2, you're going to put your frequencies. And then it's stat, calc. We want the one variable statistics. And then you have list is L1, so where it says list. And then the frequency list is L2. And then calculate. Okay, so let me show you that. So for the 84, see my midpoints and my frequencies over here. Let me move this over. Okay. All right, so stat, then edit. Okay, and I have all my lists here, so I'm going to go up and clear. So L1 will be my midpoint. So 5, 15, 25, 35, and 45. And then I'm just going to go to the right, and then I'll put my frequencies. So 4, 9, 6, 4, and 2. And then I'm going to go back to my home screen. So second, quit. Then stat, over here. Then over to calc, and my one variable stats. So my list is L1, and then for my frequency list, I'm going to put L2. So second 2 will give me L2. And then calculate. There you go. So you have your x bar, so that's your mean, sum of x squared, sample standard deviation, population standard deviation. They're really close. Not the same. This is the sample. We want the 11.860. Any questions about that? You'll have plenty of opportunity to practice. I want to do one more thing in this this section is the coefficient of variation. It's easy. Coefficient of variation, we call it CV. Oops, that's backwards. So just abbreviated. You might see CV for the abbreviation. It is used to compare, just comparing standard deviations. So if you have a sample, it's just going to be the standard deviation over the mean times 100. And then it's percent. So it's given as a percent. And it's the same thing for population, just with the Greek letters. So sigma over mu. If it'll let me write it. There we go. Nope. I don't know. There we go. Okay. Yeah. There's mu times 100%. So if we look at this question here, it says use the coefficient of variation to compare the standard deviations calculated in example 7.1 and 7.2. 7.1 was the salaries, that was the population. 7.2, that was a sample. Sometimes you can compare both. Sometimes you're just comparing standard deviations. So for 7.1, that was the salaries. That was a population. So our population standard deviation was 19.721. And the mean we had found was 74.88. Ignore that extra decimal there. So we just divide those. So 19.721 divided by 74.88. So 0.2633, we'll times that by 100. 26.34. Yeah. So 26.34%. And then we'll do the commute times. So that was a sample. So S over X bar. And that was 11.860. And then 21.4 for the mean. So let's see what that gives us. $11.860 divided by 21.4 times 100, 55.42. So we got our coefficients of variation, and then which one has a greater variability? Yeah, the second one. So commute times have greater variability. The set is more spread out. Really? That's why it has greater variability. There's more data points. That's why. So we're really just calculating that for the 2.7 and then, which one is which.